All right, IBAASL2. Today we're going to talk about the chain rule. I feel like we've been doing derivative rules for a while now, but we really just have the power rule. In the next couple classes, we're going to get a bunch more tools for finding more complicated derivatives. So before I get into what the chain rule actually is, we need to talk about compositions of functions. A composition of functions is a function within a function. Sometimes I call it like the inception of functions, if you're familiar with that popular Leonardo DiCaprio vehicle. But yeah, that movie was all about a dream within a dream. Composition of functions are a function within a function. So if we write f of g of x, that's not fog, and it's not f times g of x. This is f of g of x. That means that g of x is some function inside of f of x. So a quick example here, this has already been composed. There is a g function inside of an f function, and I'm going to quickly write what I think the possible inside and outside functions could be. When I look at this, I see that there's a square root around another function. There's lots of ways to decompose functions and figure out what the parts are. I usually just try to keep it simple. Like whatever the inside, like underneath a square root, or inside like a parentheses that's being squared or cubed or something, that's your inside function. Remember that the inside function is the g of x portion of it. That the g is always inside and the f is outside. So possible g of x for this would be x cubed plus x squared minus 5. Then the outside function is this square root. So the square root is just square rooting an input. So for that guy, we're going to say that the outside function is just the square root of x. So now if you were to take all of this and then substitute it into here, compose it, it would look like this. Now we need all that because the chain rule is when you spot a derivative that has a function within a function. So if you're trying to take the derivative of an f of g of x, it is the derivative of the outside. So remember, the f is the outside function, the g is the inside function. So this is derivative of the outside times the derivative of the inside. The inside is g, so that's the derivative of the outside. I also came up with this handy just way to say it in words, which is that you always take the derivative of the outside with the inside untouched times the derivative of the inside. So yeah, you leave the inside untouched with the first part, but then you take the derivative of it in the second part when you multiply. Okay. In this function, the outside function is something being cubed, and the inside function is x squared minus 4x. So if we are going to take the derivative, it's the derivative of the outside. Now, when taking the derivative of the outside, it's a power rule. This would come out in front, it would drop down one, and you would leave the inside untouched. So this would be 3 times x squared minus 4x, and then you drop the power down one, so that's 2. So this is the first part. This is, let me get a different color. So this is derivative of outside with inside untouched. That says untouched. Great handwriting, Dolly. Then you would do times the derivative of the inside. So this would be times the derivative of the inside. So if you just zoom in on this guy right here, you could use the power rule to say that's 2x minus 4. So 2x minus 4. So this is derivative of inside. Yeah, chain rule is all about outside versus inside. Let's see, do they want me to clean that up at all? No, we can just leave it right there. 3 times x squared minus 4x quantity squared times 2x minus 4. The next one, you have to think of this as 5x squared minus 2 to the power of 1/2. So now my inside function is 5x squared minus 2, and the outside function is something to the 1/2. So if I'm going to do derivative, it's derivative of the outside with the inside untouched. So if we're just looking at the outside function, that's a straight power rule, where you would bring the 1/2 out in front, drop it down 1, and keep the inside untouched. So the 1/2 comes out in front, inside is untouched, and then subtract 1 off of 1/2 and you get negative 1/2. Then we have to multiply that with the derivative of the inside. Now, derivative of the inside is just 5x squared minus 2. So it's straight power rule, 10x, and then that's it. I guess I didn't need that parentheses so far off. Now we're going to clean this up a little bit because this definitely can be simplified. One thing I'm seeing is this negative 1/2 needs to get kicked into the basement. Then we'll have 1/2 times 10, that's 5. So let me see. There will be a 5x up top because the 1/2 times the 10 is 5, and the x will also hang out up top. And then below, you get 5x squared minus 2 to the 1/2. And then I've seen them cleaning up those to the 1/2 and putting them as radical square roots. So we're going to go ahead and say this is 5x over the square root of 5x squared minus 2. Yep, that's it. That's the derivative. Next one. Y equals 2 over the square root of 1 minus 3x. So just like the last example, we're going to have to do a rewrite before we do anything. So I'm going to let the 2 hang out up top, but then the bottom, well, I'm really going to do 2 moves at once. I'm going to make the square root into a power of 1/2, but then move it back upstairs and make it a negative square root. I mean a negative power. Now that we've rewritten it, the outside function is 2 times something to the negative 1/2, and the inside function is 1 minus 3x. So the derivative of the outside is the power rule, that we're going to bring this power out in front and multiply and then drop that down 1. So if I'm going to write y prime, the negative 1/2 times the 2 would just be a negative 1, and then we'll leave the inside untouched, and then we'll drop it down, negative 1/2 minus a whole 1, so this is minus 3/2. So that part so far, that's just the derivative of the outside with the inside untouched, and then we have to multiply times the derivative of the inside. But the derivative of the inside is just negative 3. Now, essentially, that's the derivative, but we got to play cleanup. Some things that I'm seeing, a negative 1 times a negative 3 is going to be a positive 3, and also let's kick this guy down to the basement. So positive 3 is up top, and then we get the, I don't know, do they put it in radical form? Yeah, they do. Okay, cool. Yeah, we'll put that down. I'll do a couple steps for you guys. That goes into the bottom. And then this is essentially a square root with the inside cubed. So this is y prime equals 3 over the square root of quantity 1 minus 3x squared. Nope, not squared, cubed. Yeah, because remember that with the fraction, this part is what goes in the cradle, and this part is what goes on the power inside the radical. Okay, you guys, that's all I got for you today.